Hi there. Here we have a map of the beta globin gene in humans found on chromosome 11. So as you can see, it's one very long strand of DNA, but not the entire strand codes for the beta globin. So here we have our three blue lines, which are lines of amino acid sequences. And there are three different lines because each one is a different reading frame, depending on where you start reading the template DNA in red. So the first exon that we have is found here with the M, which is the start codon, and the start codon is over here in the DNA. Well, it codes for the mRNA, which has the start codon. And this is the first chunk that we have in the third reading frame. And then we have to skip a little bit because here we have one of the introns. And here we have the second of three exons found on the first line of the reading frame, which is coded for by this DNA in red. And you can see it lines up very well. Each one of these amino acids is coded for by three smaller letters in the DNA, one codon. And then we have a big intron over here. There's a whole lot of non-coding DNA. And then we get finally to our third exon over here in the second line of the reading frame. And it stops over here at the H. And if you see in the DNA, when this makes mRNA, this is a stop codon. So it makes sense that it ends here because this tells it to stop coding. So even though we have our three exons in the three different lines, when you cut out the introns, the DNA actually lines up perfectly. So it ends up being only one reading frame. So that's our beta globin.